Hello students, in today's session we will discuss the 062561 of May and June 2019 paper number 6, that is ATP alternative to practical. So let us start the very first question. The question 1 is saying a student is determining the weight of a meter rule using a balancing method. This is the apparatus. The student places the meter rule on the pivot. He places a load P, this is the load P, on the meter rule at the 90 centimeter mark. This is 0 and this is 100. So this is the 90 centimeter mark where the load P is kept. He adjusts the position of the meter rule on the pivot so that the meter rule is as near as possible to being balanced. As we know, this meter rule also will have its some mass and it will apply some weight in order to balance this P. So the question is saying this is right now it is balanced when the P block is placed at a distance of A from the pivot, and this is the 50 centimeter mark which is at a B distance from the mark. He records the distance A, that is 90 centimeter mark to the pivot, and record distance B, the pivot, to the 50 centimeter mark. This is A and this is B. He repeats the steps, placing the point load P at the 85 centimeter. Now this is, if this is 90, this is 100, so we can say that 85 is towards the pivot, or we can say towards the right hand side if we going in this direction. So 85, 80 75, 70 centimeter marks will be near to the pivot. So the table is showing the values of A in centimeter and B also in centimeter. So these are some values which is given. Now in the first part the question is saying plot a graph of A taking on the y-axis against B taking on the x-axis. You do not need to begin your axis at the origin. We are not required to start it from the origin. So if we talk about the A and the B, so let us first of all on this graph, first of all mention that we are taking this as the A in centimeter and this y-axis A centimeter and B also in centimeter on x-axis. Now if we have to plot the values are starting from the minimum value is 10.5 and the minimum for x-axis is 9.5 and the highest is going to 19.1 and 21.0. so you have to take the scale of the graph in such a manner that these points which we have to plot should cover at least half of the graph. This you have to remember while drawing the graph. So let us start from 0, 0 only. So I am putting this as 0 and taking it the first as 5. This is 10. So this will be 15 and 20 and 25. Similarly on the x-axis I am taking the same division 5, 10, 15, 20 and 25. Okay. Now the first value, if we start from the bottom end, 10.5. So 10.5 will be on the y-axis. So 10.5, this is 10. So this will be 12.5. So 10.5 will be, this is 10, this is 11, this is 12, 11, 12.5. So 12.5 will be 10.5, sorry, not 12.5, 10.5. so this will be 10.5. okay, and the x-axis is 9.5. so 10.5, if we plot 9.5 will be, this is 10, 7, 6, 7, 8 and 9. 9.5 will be here. So this will be my first point. Look at the values. Why I am saying this? Because 9.5, this will be 9. Look, this is 5, 6, 7, 8 and 9. So this is 9 and 9.5 will be the midpoint between the 9 and 10. So this is 9.5 and this is 10, then this is 10.5. So this is my first point according to the table. Similarly, the next is 11.8 and 13. So first I have to mark 11.8. So if I have 10 here, so this will be 11 and this will be 11.5. So 11.8 will be somewhat here. Okay, so let us point the 11.8, 10, 11, 11.5, 11.8. Somewhere here it will be my 11.8. Okay, and the corresponding value is 13 on the y-axis. So 13 will be, this is 10, this is 11, this is 12, this is 13. So this will be 13 somewhat here. So this is my second point. Similarly, I have to plot the other 2 points also, 14.1 and 16. 14.1. So if I talk about 14.1, then this will be 14 and 14.1 will be here only, and 16 according to this 15 and this is 16. So this is here somewhat 15 and this is 16 and 14.1 will be here corresponding to this point. This is 14 and this is 16. Yes, on the y-axis it is 16 here and corresponding point will be near about this point, third point. Similarly, you have to draw the other two also, which is 17.2 and 18. So let us 17.0, this is 15, 16, 17.2 will be somewhat here in this line, and the next is 18. So 15, this is 16, 17 and this is 18. So this will be your 17.2. 16, 17.2 will be here and 18 will be 15, 16, 17, 18 will be here. So if I plot this point, it will be near about this point. Okay, so this will be the point here. Fine. Now the last point is your 19.1 and 21. This is my last 19.1 and 21. So 19.1 on the x-axis. So 19, this is 19. So 19.1 will be here and 21 on the y-axis. This is 20. This will be 21. So if I draw this point, I will get some like here. So this will be the point. So here I plotted the points given on the table. So now you have to just join the points, or I can do one thing. I just took the first point and take the last point and just draw a straight line. One thing I can do here is I just take the first point and the last point and draw the straight line, or you can move freely on your hand using your hand. Okay, so this is how you have to plot. What points you have to remember is, first of all, mark the axis and also with the units as per the question, the y-axis and the x-axis. Then take the suitable scale and just plot the graph. So this will be your graph for your A part. Okay, now read the second part. Determine the gradient G of the graph. Show clearly on the graph how you obtain the necessary information. You have to show and the question you have to clearly mention that you have to clearly show on the graph. So how we calculate the gradient we have learned. So take any 2 points. I am taking 2 points with, let us say, with red color I am showing it here. I am taking the first point, or you can take any point which is easy to measure. So let us take this point as the first. Let us say this is my x1 comma y1, and let us say the another point will be my this point. Let us say this will be my x2 comma y2. So this x2 comma y2 is how much? This is 15, and y2 is, I can say, 15.5. Similarly here x1 is my 10 and y1 I can say 11. This is 11 and this is 16.5. This will be my 16.5. 16.5. This is 16 and above this is 16.5. Okay, so here I have the values of. So how will we draw the gradient? Just make a triangle using the. So this will be my gradient. So gradient will be, if I talk about the gradient, then what I can say, my gradient will be equals to y2 minus y1 upon x2 minus x1, and the values are y2 is 16.5 minus 11 upon x2 is 15 minus 10. So these are my values for the x2 and x1. So by solving this, you can solve using your calculator with you. 16.5 minus 11, which is equals to 5.5, and this is again 5. So if I divide 5.5 by 5, it will be 1.1. So what is the value of gradient is 1.1. Now read this is the solution for your B part. Now read the C part. Calculate the weight W1 of the meter rule using the equation W1 equals to G into P, where P is your 1 Newton. You have to use this formula where P value is given to you and W1 you have to calculate, and the G is already we have calculated in the above part. So W1 I can easily say is equals to G into P, where G is 1.1 and P is also 1. So I get the value 1.1. So what is the value of W1 is the weight and the unit will be Newton. So you have to write the unit also. If you forget this unit, you will lose your marks. Now the D part. Suggest any one practical reason why it is difficult to obtain accurate reading for A and B in this type of experiment. What are the problems or the practical reason or the difficulties you face in calculating the readings of A and B that you have to suggest? So what are the problems simply we face is, first we can say difficulty in achieving exact balance. The exact balance of the rule is very much difficult to achieve. Now the second, the load or the object which is placed may get slip easily. So this is the another one problem we face. And difficulty you can also say in if the object is bigger difficulty in judging the center point. Where will you calculate the distance from the pivot? The center of P, that is the pivot. Okay. Now the E part. Student, measure the mass of the rule on a balance. Write down the mass M shown on the balance to the nearest gram. You have to calculate to the nearest gram. So this is the reading on the given and the weighing balance. So if I talk about the nearest gram, so I will write rounding off to the 3 significant figure will be 113 gram will be the answer. Now the next part. Calculate the W2 of the meter rule using W2 equals to mg, where g value is given in. Look at the value. Be careful, students, here. The value is given in Newton per kg and the mass that we have calculated in the above part is in grams. So if you have to write down the value of m in this equation, so first of all W2 is equals to m into g, then you have to take the mass in kilogram. So I have divided it by 1000 and then multiplying it with 10. So by solving this you will get the answer as 1.13 Newton. If you ignore the units of mass and you kept it in gram only, then you will lose your marks and you will get the wrong answer. Okay, now the second part. State and explain whether the value of W2 can be considered equal to W1 obtained in part C within the limits of experimental accuracy. So there we have two values, W2 which is 1.13 and W1 which is 1.1. Are the values within the limits of experimental accuracy? Yes, these are the values of limit in experimental accuracy because the values are very close. So we can say yes, the value of W2 can be considered equal to W1 because the values are very close. Okay. So this is the first question we have solved. Now moving on to the next question. Read the question. A student is determining the resistance of a resistance wire. The circuit is shown. This is the power supply, this is the switch, this is ammeter, this is the resistance wire whose resistance is to be calibrated. This is a voltmeter, this is a sliding contact C, and this is length L from this and B. So record the current I in the circuit as shown on the ammeter. This is the ammeter reading. So what is the ammeter reading? This is 0.4, this is 0.6. And what are the total number of division? If I say the total number of divisions are 10, so each division will be 0.02. This is 0.02 division. So 0.02, so I can write it like this: 0.02, 0.42, this is 0.44, and this is 0.46. So I can say it is near in between. If I zoom in, this line is near between these 2 points. So 0.546 and 0.47 in between this. So I can simply write it like this is I is equals to 0.465, or if I round it off, then I can say 0.47 ampere. So I is equals to 0.47 ampere. Don't forget to write the units again, student. Okay, now the B part. The student places the sliding contact at a distance L from B. In the figure, left hand side, from the left hand side B point is there and the length is 20 centimeter. She records the potential difference across the length L of the resistance wire. She repeats the procedure using L. Values are varying according to the length. All the readings are in this table. Calculate and record V by L for each value. Complete V by L column heading also. So this is the heading. First of all, let us complete the heading. V by L. V is the volt and L is measured in centimeters. So the reading value will be L by centimeter. Okay. Now V by L reading, if I say what will be the V by L reading. So V is given to you, L is also given to you. You have to just calculate the values. You can use your calci. So 0.5 divided by 20, 0.5 divided by 20, you get 0.025. Again next 0.92 divided by 40, you get 0.023. The next you get 1.62 divided by 60, you get 0.027. 2.08 divided by 80, you get 0.026. 2.4 divided by 100, 0.024. So these are the values we have completed. Now C part. Look carefully at the values of, tick the box to show conclusion. V by L is approximately constant. V by L is decreasing as V increases. Okay. V by L is decreasing as V increases. V is increasing here and V by L is decreasing. No, here it is increasing. So this is wrong. V by L is increasing as V, here it is decreasing also. It is decreasing. No, this is also wrong. There is no simple pattern V by L in the result. So we can say here approximately it is constant. Yes or no? It is approximately constant, we can say. So the first box will be the right answer according to this question. Now justify your conclusion by reference to your results. So we can say as the ratio is almost, or we can say the values in the ratio is almost, as the value of ratio is very close or almost constant. So that is why we can say here it is approximately constant. Now the next part, calculate the resistance of 100 centimeter of the resistance wire using R equals to V by I, that is Ohm's law. Okay, where the V is the potential difference across 100 centimeter of the resistance wire. Use the value of current I from part A. Give your answer to a suitable number of significant figures for this experiment and include the unit. So we have to calculate the resistance of 100 centimeter of. So we can say to identify the resistance, first of all the potential difference for length equals to 100 centimeter we can obtain by the table, and according to the table this is given to us. 100 is 2.4 volt. At L equals to 100, the value of voltage, that is the potential difference, is 2.4, that is 2.4 volt. Now we have to find out the value for resistance. So R is equals to V by I, and I we know that from A part it is 0. How much it is? 0.47. So it is 0.47 ampere. So we can just put up the values, that is 2.4 divided by 0.47. So you will get the answer 5.1 ohm. That is the unit of SI unit of resistance, that is ohm. So this is the answer for D part. Now the next part. In this experiment, it is sensible to keep the temperature of the resistance wire as close to room temperature as possible. Suggest one way to minimize the rise in temperature of the resistance wire. How can we minimize the rise in temperature of the resistance wire. You have to suggest any one way. So we know that by keeping current low, by keeping the value of current in the circuit very low, we can minimize because as the current increases due to heating effect of current, the temperature of the conductor or the resistance wire will also increase. So this will be the one way. Or you can also do one more method by switching it off, switch off the circuit between readings. When you are taking the readings at different length, in between the readings you should first switch off the circuit, then take the another reading. So in this manner you can maintain the temperature in order to minimize the rise in temperature. Any one you can write, both are correct. You will get the same marks for any of the point. Now the next is draw the circuit symbol for variable resistor or rheostat. We all know that this is the symbol. A rectangular box with an arrow is the symbol of a variable resistor. Okay. Now moving on to the third question. Read the third question very carefully. A student is investigating the rate of cooling of water under different conditions. A greater rate of cooling occurs if there is a greater change in the temperature during the same period of time. This apparatus shows a clamp stand, a bench. This is the lid. This is the thermometer. This is the hot water, and this is the beaker, and this thermometer is inside the hot water. Now the A part. The thermometer shows the room temperature, that is delta R, at the beginning of the experiment, theta R. What will be the value? Read this thermometer. This is at this point, which is equals to, we can say, 1 division is equals to 1 degree centigrade. This scale is in degree centigrade. Look here. Okay, so this will be 24 degrees centigrade. Look at the readings. It is 24. If I zoom in, this is 25, and it is just one line division before the 25. So it is 24 degrees centigrade. The student pours 200 centimeter cube of hot water into the beaker. She records the temperature theta of the hot water at T equals to 0. She immediately starts a stop clock. She continues recording the time and the temperature after every 30 seconds. The readings are shown in the table 3.1. So these are the readings in table 3.1. She has added the hot water, and then he is measuring the temperature after 30 seconds. So these are the reading. The student repeat the procedure using a metal can. Once this is using a beaker, here it is written, and this is using a can, which is painted matte black in place of the beaker. The readings are shown in table 3.2. The complete the following headings in the 3.1 and 3.2. So if I complete, these are in seconds, and this is in degree centigrade. Again, this is in second, and this is in degree centigrade. So we have done this part. Look carefully at the readings in table 3.1 and 3.2. Tick the box to show your conclusion from the reading. The water in the beaker, the first box is the water in the beaker has a greater rate of cooling than the water in the can. So if I look, it is the initial 94, it is at 93. After 30 seconds, there is a drop of 1 degree. Here is a drop of 2 degree. Again here it is 1, it is 1, it is 1, it is 1, it is also 1, now 1, and here it is 1, here it is 1. So there is no such, so this is the wrong answer. The water in the beaker has a smaller rate of cooling than the water. No, we cannot say. There is no significant difference. Yes, there is no significant difference between the rate of cooling of the water in the beaker and the can. So this is the right answer. Justify your conclusion. We can justify our answer that there is no significant difference. There is no significant difference between the rates of the cooling of the water and the beaker and the can, as the difference is very small. It is only 1 degree centigrade as per the readings given in the table. Okay. Now the C part. A student in another school carries out the experiment and reports the rate of cooling of the water in the can is different from the rate of cooling of the water in the beaker. He plans a change to experiment to find out whether this difference in the rate of cooling is caused by. First bullet is saying the matte black surface of the can being a better radiator of thermal energy than the shiny surface of the beaker. Here the can is having a matte black surface and than the shiny surface, and beaker is having a shiny surface. Okay, and then the second part, the metal of the can being a better conductor of thermal energy than the material of the beaker. As can is made up of metal, it is having a better conductor than the material of the beaker. So what are the two suitable changes to the apparatus that the student could make? So one thing we can do is, if the can is already matte black, one thing we can do, we can also paint black the beaker also. So by using, we can say by using a black painted beaker, there will be a more accurate, we can say, observation for the experiment in identifying the rate of cooling. Now next, the metal of the can being a better conductor of thermal energy than the material of the beaker. So in this case, we can do one thing by using a shiny can. Instead of using a matte black surface of the can, we can use a shiny can, so that the shining surface of the beaker and the shining can is one and the same thing. Now suggest two variables that should be controlled. Here we have to write down the control variables of this experiment. If we are not able to control, then we will get the different readings. So what are the two control variables? Yes, by taking equal amount of or equal volume, by taking equal volume of water in both cases, that is your beaker and the can. And second, same initial temperature of water and the same room temperature should be there. When you are conducting the experiment, there should be same initial from which you are starting your stopwatch. So same initial temperature of water in both the beaker and the can, and the same room temperature. So they should be conducted in the same room, so that you will get the proper observation and the conclusion. State one precaution that you would take care in order to record accurate temperature readings. So what are the errors, or you can say precautions, that should be keep in mind while performing this experiment related to your thermometer? Yes, the thermometer should not touch the beaker or the can or the walls of the container. Okay, otherwise it will read the different readings. Thermometer should not touch the beaker or can. The next, you can say the perpendicular reading, the reading while you are taking the readings of thermometer, your eyes should be perpendicular viewing of the thermometer in order to take correct reading. Okay, and the next, by continuous stirring also you will get the same reading. By continuous stirring you will get the accurate temperature reading. So this is about the third question of this ATP paper. Now the most important and the most student having the most doubt how to solve the last question of the ATP, that is to investigate the experiment. So please now listen me very carefully how to attempt this question. You will get all your answers in this question. First of all, read the question very carefully. A student is investing the work done required to pull a box containing some masses up a sloping wooden board as shown in the figure. Look at the first of all figure, what we have there. There are some masses kept. This is the wooden board on which wooden blocks on which there is a wooden board, and this is a string tied to a box in which some masses are kept. This is already given to us. Now we have to plan an experiment to investigate how the work required to pull the box up the slope depends upon the mass and its content. This is very important point to be noted here. What is that? How the work required to pull up the box up the slope depends upon the mass and its content. So these are your independent variable that on which quantity does the work is depending. So these are your independent variables which we will change in our experiment. So this is our independent variable. You are not required to write all this in your answer sheet. Here I am just writing in order to explain you. Okay, so independent variables is what? Independent variable will be a mass of the box and its content. Now the formula for the work done is given to you. Formula is force into distance moved in the direction of the force. So in order to calculate the work done, what we are supposed to require is we are required to measure the force and the distance moved. These two are required in order to calculate the work done. So what will be the dependent variable? What we are calculating is your dependent variable. So we have to calculate the dependent variable, and dependent variable is work done. So the work done will be your dependent variable. Here as per the figure, we are given the apparatus, a wooden board, a box that is a string attached, a selection of masses that fit in the boxes, a meter rule is also given, and an electronic balance. These are all the values which is given to us. In your plan, you should list any other apparatus. Look, these are the points which you have to be very careful while writing your answers. The answer should contain all the proper answer which will cover all these bullets point. Then only will you get the full marks in this investigating experiment question. That is the last question. So you have to list any other apparatus that you are using. Briefly explain how would you carry out the investigation, including the measurement you would take. What are the measurement you are supposed to take, that you have to explain briefly. State the key variables that you would control, that is your control variables you have to mention. Okay, here you have to mention the control variables also. What are the control variables that you have to control while performing this experiment? Now draw a suitable table with column headings to show how would you display your readings. You are not required to enter any readings in the table. With the column heading, this is very important. Table you have to draw with the column headings. What do you mean by column headings? It means the variables which you are using and their units. With their units you have to mention in the table. And next, explain how would you result to reach the conclusion. Your result and how will you reach the conclusion. You may add to the diagram if it helps to your explanation. So what else? As per the requirement here, I have told you in order to calculate the work done, we are supposed to calculate the force required and the distance moved by the block. So if we see the diagram, here it is nothing shown through which we can calculate the force. So one thing I can add up here is this. I am just connecting a, let us say this is my force meter, or you can say Newton meter, which measures the force, or you can say the force meter, which I have attached to the string in order to calculate. Here I will get the reading of the force. And one more thing, in order to calculate the distance, I have a meter rule, so I will place the meter rule at this point in order to calculate the distance moved by the box. This is my meter rule. I just do some markings in order to show that this is my meter rule. This is my meter rule. Okay, so let us first of all add our values, that is apparatus. My apparatus, I can say, other than given material, other than given apparatus, I am adding Newton meter and meter rule as per the question shown in the figure 4.1 and figure 4.1. So the first point I have covered, that is the list any other apparatus that you would use. Now read the next. First of all, now I am mentioning the independent variable. So if I am talking about independent variable, that will be the mass of the box. Look, independent variable are those variable which you are changing, you will change in each step. So here what we are performing, where what I will do, I will change the content in the box so that the value of force will change, and what I will do, I will measure the distance moved by the box and I will control the distance of the box covered. I will fix up the distance, let us say about 20 centimeter or 30 centimeter, which may ever be suited values as per the apparatus given. And I will not change the angle of this slope, because if I change the angle, then the values will also change. So I will control two variables, that is the distance measured and the angle of slope. So the independent, if I talk about independent variable, that will be the mass of the box and its content, that I will change in each step, and according that only dependent variable will be, my dependent variable will be the work done as mentioned above, required to pull box. And the control variable, if I talk about control variable, so the control variable will be my angle of slope, that I will not change, or you can say the height of the blocks. These are the blocks, these are the height of the blocks, I will not change. Okay, so the height of blocks, and the second is the distance covered by box. This I will not change. Now the method, how will I perform this experiment? So what I will do is, I will generally put some mass, or you can just take some values of the masses what we generally perform in our experiment or in the lab. So what I will do, I will put mass of 50 gram in the box and pull the string attached with Newton meter to measure the force required to pull box at constant speed. Because I am not changing the acceleration, I have to pull the box at constant speed up to a fixed distance. And next point, measure the distance moved. Measure the distance moved using the meter rule. Let us say I have moved it around 30 centimeter, okay, as shown in the figure, and calculate the work done required in joule by using formula work done is equals to force into distance. Now the next point, I will keep the same angle of slope, keeping same angle of slope, and for same distance I am not changing the distance, and for same distance changing the mass. What I am changing? Independent variable, that is changing the masses in the box, or you can say the mass in the, or you can say mass content by, let us say first we have taken 50 gram. Now I will add again 50, that is 100, 150, 200 and so on in grams in the box. And repeat the above step, because I will not write it again, and just write down that repeat the above steps to measure force required to pull the box. So now we have read up to 5 readings. 4 we have already taken. 4 to 5 readings you have to take. Repeat the steps, and then we have to draw the table. So the table will be drawn in such a manner, including all your, for example, let us say this is my table, and if I draw, let us say this is serial number, this is mass, this is force, this is distance, and this is work done. So serial number, serial number, mass, that we are taking in grams, or should we take it in kg also? Let us take it in kg because we are required to do it in SI units only. So it is, let us say kg, masses are in kg. Then this is the force, which is denoted by F, is measured in Newton. Then the distance is denoted by D, which is measured in meter. And then the work done, which is equals to force into displacement, and it will be in joule, because if you are taking joule, then you have to take the SI units. So this is, you have to draw the table using the headings. What the question is saying, look, Draw suitable taking, show the column heading. That is the table and that is the column heading. These are the heading with their respective units. So you have to take at least, let us say 5 units we are taking, 5 readings, 1, 2, 3, 4, 5, and masses are 0 0.05, 0 0.1, 0 0.15, 0 0.2, 0 0.25. So up to 250 grams we have taken the mass in the box, and the distance is same, that is 0 0.3, that is 30 centimeter, that we can mention here as per our method and investigating experiment. Now at last the conclusion. How we will write the conclusion? We will draw the graph. Okay, draw graph and show taking mass in kg, that is your independent variable, on x-axis. Always take your independent variable on x-axis, that the values or the quantities which you are changing taking on the x-axis, and the work done, that is your dependent variable, which is measured in joule. Work done in, that is your dependent variable, on your y-axis. Always remember independent on x-axis and dependent variable on y-axis. Dependent variable are those variable or the quantity or the value which you are calculating, and independent variable are those values or quantities which you are changing in each step, and control variables are the constant value which you have to perform, take the same values in all the steps. Okay, so it should be clear in your mind what are independent, dependent and control variables. On y-axis, to show how work done required to pull the box depends upon mass of the box and its content. So this is how you have to perform the last experiment. So if we let us check all the bullet point list, that is the apparatus we have done. Next point, explain briefly, that is your method that we have done. Okay, then state the key variables. All the key variables we have mentioned, independent, dependent and control. So no need to worry. Draw a suitable table with the column headings. After the method we have mentioned the table with the column headings. So this is also we have done. And then last, the conclusion part, and this is the conclusion of this experiment. So I hope now it is clear to you how to write down the last answer. So this is all about the ATP May-June 2019 paper number 6. So till then, keep learning and enjoy.